Section 2.4 is called complex numbers. So in this section, it's a lot of review from Math 2 and Math 3 about operations and how to solve equations, simplify radicals, everything to do with I, the imaginary unit I. So as a definition, the imaginary unit I is defined as I is equal to the square root of -1. So if we square both sides, that implies that I squared is -1. So that's something that we need to know. A definition of a complex number, if A and B are real numbers, then A plus BI is defined as a complex number written in standard form, where A is the real part and then BI is the imaginary part. So we can classify numbers as real or imaginary. So pretty much anything with an I is an imaginary number. Anything that is missing an I is a real number, and then we can combine the real parts with the imaginary parts to create a complex number. So this number right here doesn't have an I, but we can think about it as -1 plus 0i. And then this obviously has an A and a BI. And this is the same thing as 0 plus I square root 2. So it has a real part and an imaginary part. And then this one obviously has a real part and an imaginary part. Adding and subtracting complex numbers. Okay, so if A plus BI and C plus DI are two complex numbers written in standard form, then their sum. All this is saying is if you're adding two complex numbers together, the sum will equal if you add the real parts together plus add the imaginary parts together. And the same thing goes for the difference. If you subtract them, subtract the real parts plus subtract the imaginary parts. Therefore, in the complex number system, okay, since we have i's now, we're not just in the real number system anymore. If we have A plus -A, that's 0, and then BI plus -BI is 0i. So this is defined as the additive identity in the complex number system, because if I add this to any number, it keeps it to be the same. So the first example, adding and subtracting complex numbers. So all this is wanting us to do is add the real parts. So I have 3 plus 2, which is 5. -I plus 3i is positive 2i. And this is my answer. It must be written in the form of A plus BI, where the I part goes second. So this is correct. For part B, go ahead and distribute the negative. So you're going to get 3 plus 2 minus 3i. And then plus -5. So actually, I shouldn't put a plus. -5. And then plus I. So adding the real parts together, all this becomes 0. And then -3i plus I is -2i, which we can simplify as just -2i. Multiplying. Okay, so for part A, distributing the 5, we're going to get -10 plus 15i. For part B, basically just distribute, just like we know how to. And we're going to get 8 plus 6i minus 4i minus 3i squared. Okay, where we can combine like terms right here. So 8 plus 2i, but then this we know is defined I squared. Since I is equal to the square root of -1, that implies that I squared is equal to -1. So this is the same thing as -3 times -1. Okay, where this becomes positive 3. 8 plus 3 is 11. So this just becomes 11 plus 2i. For C, distributing the 4i, excuse me, we're going to get -4i plus 20i squared, where we know I squared is -1. So this is going to become -4i plus 20 times -1, which is -4i minus 20, but we have to write it in standard form. So standard form is a plus bi, which means I'm going to rewrite this as negative 20 minus 4i. For part D, expanding this out, 5 minus 3i squared means to take 5 minus 3i and times it by itself. So we're going to get 25 minus 15i minus 15i plus 9i squared. This will be 25. This becomes negative 30i. And then this becomes minus 9 because I squared is negative 1, which means combining like terms, you're going to get 16 minus 30i. Complex conjugate. So if we're asked to multiply a complex number by its conjugate, all that means is the sign that separates the real and the imaginary part, you just change it to the opposite sign. So if a plus bi is our complex number, its complex conjugate would be a minus bi. If we're given a minus bi, then its complex conjugate would be a plus bi. So the sign changes. So for example 3, if we're given 3 plus I, its complex conjugate would be 3 minus I, and then just multiply it through. We're going to get 9 minus 3i plus 3i minus I squared. Negative 3i plus 3i cancel. I squared we know is negative 1, so this is 9 minus negative 1, which is 10. For B, 5 minus 4i times 5 plus 4i because its conjugate signs change. And then distributive property, we're going to get 25 plus 20i minus 20i minus 16i squared. 20i and negative 20i cancel out. This becomes negative 1, so we're left with 25 minus 16 times negative 1, which makes this positive 16, so this makes this 41. Okay, and the thing that I want you guys to notice is in both solutions, we're just left with a real number. So that means that when we multiply a number by its complex conjugate, that means that we're going to be left with a real number. There's no more imaginary number floating around in this problem. So if we're asked to do something like this, to rewrite a quotient in standard form, okay, kind of like what we learned in the past where we can't have a radical on the bottom, square root, we can't have an imaginary number on the bottom. So if we want this to not be imaginary anymore, we can multiply top and bottom by the complex conjugate. So that way there's no more imaginary number on the bottom. Okay, so this is going to become, if I multiply top and bottom by the complex conjugate, so 3 minus 2i, we're going to get 9 minus 6i minus 6i plus 4i squared. Oops. Just write it over again. Plus 4i squared. On the bottom, we're going to get 9 minus 6i plus 6i minus 4i squared, where these cancel. On top, we're going to have 9 minus 12i. This becomes negative 1. So 4 times negative 1 is negative 4. On the bottom, we're going to have 9 minus 4 times negative 1 because I squared is negative 1. So then we're going to be left with on top 5 minus 12i over 13. Okay, and we can't leave it like this because we want it as a plus bi. So because both of these numbers are over 13, I'm going to split this apart to the real and the imaginary part. So 5 over 13 minus 12 over 13i. Okay. Rewriting a expression in standard form. So taking a radical times another radical. I'm going to first simplify this guy. So square root of -3, we can think about as the square root of, looks terrible, -1 times 3. And then the square root of -27 is the same thing as -1 times 27, like that. Well, we know the square root of -1 is I. So I'm going to take I and pull it out. So this is going to be I square root of 3 times I square root of 27. Square root of 3, I can't break this down anymore. So that's as simple as this can get. So I'm going to leave this alone for now. But 27, using a factor tree to break down the radical, 27 is 9 times 3, and then 3 times 3. So because I have a pair of 3s, that means that 3 is a perfect square that divides into 27. So I'm going to pull that out. So I'm going to be left with I square root 3 times 3I square root of 3, because there's a 3 left over that doesn't have a buddy. So it's going to stay on the inside. And this 3 as a pair comes outside. So I'm going to multiply I times 3I to get 3I squared. And then the square root of 3 times the square root of 3 is just 3, which makes this 9I squared. But we know I squared is -1, so this is just -9. For B, okay, same idea. We can rewrite this guy as the square root of -1 times 80 plus the square root of -1 times 20, which makes this I square root of 80 plus I square root of 20. Okay, so we're going to try to simplify square root of 80. So 80 I know is 4 times 20. 4 is the same thing as 2 times 2. So there's a pair right there. 20 is the same thing as 4 times 5. And then 4 is the same thing as 2 times 2. So I have a pair of 2's and another pair of 2's. So that means that 2 is a perfect square twice. So I can pull out 2 2's, which means I can pull out 4. And then 5 is the number that's left over. So this becomes 4I square root of 5 plus 20. We know it's 4 times 5, 2 times 2. So this is the perfect square I could pull out. And then this number doesn't have a buddy. So 20 is going to be the same thing as 2 square root of 5. So 2I square root of 5. Okay. So because these are both square root 5s, okay, I can add their like terms. It's kind of like if it was 4x plus 2x, because they both have a square root 5, I can add the numbers in the front. So 4I plus 2I is 6I square root of 5. For part C, 4 minus the square root of -2 times 4 minus the square root of -2. Okay, I'm actually not going to simplify this part until the very end. I'm going to distribute first. So we're going to get 16. 4 times negative square root of -2 is minus 4 square root of -2. And then times another -4 square root of -2. Negative times negative is positive. And then square root of -2 times square root of -2 is just -2. So this is going to be actually just -2. So I'm going to take away that plus sign. Okay, combining like terms, I have 16 minus 2, which is 14. And then -4 square root of -2 minus another 4 square root of -2. These are like terms because they both have the square root of -2. So adding the coefficients, I have -8 square root of -2. Then square root of -2 is the same thing as the square root of -1 times the square root of 2, which is I square root 2. So this is going to be 14 minus 8i square root of 2. Okay, last examples. So complex solutions. So number one, when you're solving something like this, x squared, that means you're going to have two solutions. So we have to be careful when we do this and remember an important step when we do these. So subtract 12. And we're going to get x squared is equal to negative 12. Square root both sides. You're going to x is equal to plus or minus. Okay, square root of negative 12 is the same thing as I square root 12, which means that 12 we can simplify as 2i square root of 3. So this is plus or minus 2i square root of 3. For B, okay, since it's telling us already that there's complex solutions, you could try to factor this, but unfortunately this won't factor. So that means that we need to do quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 5, b is negative 4, and c is 1. So negative 4 is going to be 4 plus or minus the square root of negative 4 squared minus 4 times 5 times 1 all over 2 times 5, which makes this 4 plus or minus negative 4 squared is 16. So this becomes 16 minus 4 times 5 is 20 times 1. So this is 16 minus 20, which is the square root of negative 4 all over 10. Square root of negative 4 is the same thing as I square root of 4. And the square root of 4 is 2. So this is 2i. So this is going to be 4 plus or minus 2i all over 10. Okay, before I split this apart, I notice that 4, 2, and 10 are all divisible by 2. So I can break this down as 2 plus or minus I over 5. So x is equal to 2 plus I over 5 or 2 minus I over 5. Okay, or you could write it as, or you could say 2/5 plus 1/5 I or 2/5 minus 1/5 I. But either one is okay. I like this one just because it's a little bit cleaner. Oops, that was weird. This one's a little bit cleaner, but either one is correct. And this is the end of 2.4.